Objective: to understand the motion of a projectile body. When an object is thrown vertically upwards, it undergoes one-dimensional motion as its velocity and acceleration lie on the same line. But when an object is thrown at an angle theta with the horizontal, its velocity and acceleration do not lie on the same line. Hence the projectile follows a two-dimensional motion. To analyze this two-dimensional motion of the projectile, we will use the fact that equations of motion are valid in each of the two dimensions. Let the plane of the projectile be an xy plane, the point of projection be the origin, the x-axis be along the ground, and the y-axis be perpendicular to the ground. The x-coordinate represents the displacement of the projectile along the Earth's surface, and the y-coordinate represents its perpendicular displacement from the surface of the Earth. The initial velocity of the projectile u can be resolved into two mutually perpendicular components, u cos theta in the x direction and u sin theta in the y direction. Acceleration along the x direction, ax, is 0. Upon substituting ax and ux, the equations of motion along x direction are vx is equal to u cos theta, x equals to u cos theta into t, and vx square minus u cos theta square equals to 0. Hence the projectile has constant velocity in the x direction throughout the motion. One can observe that if the sun is directly overhead, the shadow of the projectile moves with constant velocity. Due to gravity, the projectile's acceleration along the y-axis is minus g. Upon substituting ay and uy, the equations of motion along y direction are Vy equals to u sin theta minus gt, y equals to u sin theta into t minus half gt square. Vy square minus u sin theta square equals to minus 2gy. The motion of the body along the y-axis is equivalent to its free fall motion. If the projectile is observed from the plane of projection, the motion of the object exactly resembles the motion of an object thrown vertically upwards with u sin theta. From the equations corresponding to its displacements along x and y axes, y equals u sin theta, x by u cos theta minus half g x by u cos theta whole square. Thus the equation of trajectory of the projectile is y equals to x tan theta minus gx square by 2u square cos square theta. As you can see, the equation is a second-order polynomial in x, which indicates that the trajectory of a projectile is a parabola. Time of flight. If the projectile returns towards the surface after time t, its displacement in the vertical direction y becomes 0. Hence, at time t, 0 equals u sin theta t minus half gt square. Hence, the time of flight t is equal to 2u sin theta by g. Maximum height. When the projectile reaches its maximum height, h max, from the surface of the Earth, its vertical velocity vy becomes 0. By substituting, vy equals to 0 at y equal to h max in the third equation of motion, 0 square minus u square sine square theta is equal to minus 2gh max. Thus, h max equals to u square theta by 2g. Range. Range is the distance of the point on the ground where the projectile strikes from the point of projection. As the motion of the projectile is uniform along the x direction, its range is equal to the product of its velocity in the x direction and the time of flight. Upon substituting the value of t, r equals u cos theta into 2u sin theta by g, which can be expressed as r equals u square 2 sin theta cos theta by g, which equals to u square sine 2 theta by g. Summary. For a projectile thrown with speed u at an angle theta with the horizontal, the equation of trajectory is x tan theta minus gx square by 2u square cos square theta, which indicates it is a parabolic curve. The time of flight is 2u sin theta by g. The maximum height is u square sin square theta by 2g. The range is u square sine 2 theta by g.